All right, last section on 3-1. We're going to talk about decay, and in this case, we're going to talk about radioactive decay. But any of our example word problems are going to work fairly similarly. First, we're going to find ourselves our equation, which is right here. And so it's going to ask us questions based off of that formula. We just need to be able to plug things into the exponent properly. So what's the initial mass when t equals 0? So let's check it out. Y equals 25 times 1/2 to the 0 over 1599. That's the same thing as saying 25 times 1/2 to the 0. Anything to the 0 power is 1. So when we started, there are 25 grams of this radioactive radium available. So now we want to see how much is available after 2,500 years. So we're going to go to B. And so we'll say y equals 25 1/2. And so for our years, we'll go 2,500 over 1599. And so remember to put this in parentheses, the mistake I made a video ago. On the exponents, make sure you plug it in there correctly into your calculator with the proper parentheses, and the answer that you're going to end up with should be 8.46. So take the time, plug that in, make sure you can get 8.46 to pop up. When you get that correct, flip over and let's try problem 73. So try 73 first, pause the video. When you're ready to go, press play, and we'll look at how we get the answers. All right. Answer for A, we want to find that initial value, Q of 0. So we're going to say 16 times 1/2 times, or to the 0 over 24 100. Anything to the 0 power is just 1. So we start with 16, and in this problem we are doing grams as well. So 16 grams is what we're going to start with. For B, we're going to take our equation, and we're going to plug in the number of years they suggest, 75,000. And I'm putting that in parentheses because you'll need to put it in parentheses on your graphing calculator. And 24,100 is our initial value in the exponent. Plug that in correctly. If you did it right, you end up with 1.85. So after 75,000 years, there are 1.85 grams left. All right, and then we can go to our graphing calculator, and this one is going to start at 16 and decrease. And so that's just a sketch of it. We could plug this into our graphing calculator. I know it's going to look like that, though, because I found my initial value. And on this one, I know that we're decreasing on this because I've got a fractional exponent. And remember, fractional exponents are like saying negative x, which means we're decreasing. We talked about those problems in the initial videos. All right, so that's it for 3-1. Please try those, make sure those 5 problems are written down so I can check them off for you. And any questions, let me know in class.